Okay, so we want to compare and contrast blue and red shifted light. All right, now, got a lamp and nothing's moving. The light is going to look like that. All right, same for each. So they're going to see the same, and it's a little more spread out over here, but they should be the same, equally same. So,
Miss Dwyer to the office, please.
all right, and then, but when the lamp, if you put it on a conveyor belt like this, you're going to get the Doppler effect, where the weight, where it's moving at something, the red get the red. The wave gets crushed. Here, the wave gets spread out. All right. So this would be, and this would be, oh, yeah, 710 hertz. All right. Now, since this is light, they call this blue shifted and they call this red shifted because Roy G, it's G, of the colors of the visible light. So anything that's moving away, that they get shifted this way, anything moving towards gets shifted to the blue end. All right. Now here is a definition. So red shifted light is when your observed light, its wavelengths go up and its frequencies go down due to the source of the observer moving away from each other. And blue shifted is the opposite, where your observed light's frequency goes up and the wavelength goes down. I said those in an opposite order. And here they're moving away from each other. All right. The reason of this is because red light's wavelengths are greater than blues and its frequencies are less than blue's frequency. And that's why. And that's what we need to know about what they are.